Hey guys, I feel really bad that I didn't get to go through all of our notes today, so I wanted to make a video that went through the notes for day 1 of week 7 that went over the key characteristics of rational functions. Dun, dun, dun. So we have already done number 3, number 2, and number 1. Oops, I didn't even have all that stuff there. We went over some awesome stuff there. So I want to pick up with number 4, okay? So for number 4, we're going to look at r of x, and I think on your worksheet it might say s of x, and I apologize. It doesn't really matter there. What matters is the equation here. So we're going to find all the awesomeness, the vertical asymptote, or totes, the horizontal asymptote, which always has one, the x-intercept, the y-intercept, talk about end behavior, and if there's a hole. Even the holes at the bottom, you actually should look for that first. So I have 2x plus 5 and I have x plus 1, and I know for certain I do not have a hole because I don't have a matching factor on top and bottom like I might have coming up, but let's stick with number 4. All right, so when I do this, I do want to start always with the denominator. So step 1, you want to take your denominator equal to 0. And the reason that is because fractions have one rule and one rule only. You cannot divide by 0 ever, ever, ever. It'll give you a nice error in your calculator or anything that you're going to try and do. So I'm going to take x plus 1 and I'm going to set it equal to 0. When I say that, what I mean is do a little bit of algebra. What value would I plug in for x that would actually make this 0? And it ends up being -1. For the most part, you do end up just changing this guy's sign unless there would be like a 2 here or a 3 here, some kind of coefficient. But -1 plus 1 would give me 0 in my denominator, which I don't want. Okay, so that value I cannot have. That guy there is x. That's going to give you your vax, your vertical asymptote. So my vertical asymptote is x equals -1. So here is my x-axis, whoop, 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 and I look and I see -1, and I'm going to put a dotted line. And it's dotted because asymptotes are invisible boundary lines. Remember we talked about asymptotes as if like we were going to go play a game at a park or something, and we're like, okay, the boundaries are from that tree to that tree. If you cross it, you're out. It's not really a line that's there, but you like visualize it in your head, okay? Now I move on to my horizontal asymptote, which is step 2. Step 2, what I want to do is bring the top into the picture, and I want to see if I have an x in the numerator. If I have an x in the numerator, then I have some options. If I don't have an x in the numerator, kind of like the number 1 that we did, then, or number 2 that we did, then you're going to have it equal 0 always. So if you don't have an x in the top, we're going right to y equals 0, but we do, so we have to do some work. We want to see if these x's match, and they do. And what I mean is I have 2x to the first power over x to the first power. So I look for matching x powers. Look for matching powers, matching degrees, I guess I should say, because I want the highest power. Matching, ooh, my horrible handwriting, sorry guys. Degrees. If I have matching degrees like I do here, what's going to end up happening is they're going to cancel out and they're going to leave me with my horizontal asymptote. Hey! H-A-Y. Hey! So y equals 2. And that makes me excited because I already know that these two answers are also 2 because the horizontal asymptote is like the end behavior asymptote. So here's my y-axis. Here's the elevator. I want to get off at level 2. So level 2, I'm also going to have a boundary. Tree to tree, visualize. All right, so just to recap, vertical asymptote got from the denominator. Horizontal asymptote, I kind of get from the denominator and the numerator to see if they match. Now comes my intercepts. Intercepts are places or points that you cross over your x and or y axis. So that we're going for our x-axis, our x-intercept. That means y is 0, all that fancy stuff, but really what we're going to do now is take our numerator equal to 0. Okay, so just like we took the denominator, we're going to take our numerator. Now this guy's a little bit different. He's not x plus 5, which would just give me negative 5. He's 2x plus 5, which means I have a little bit more math to do. So I'm going to subtract 5 from both sides and get 2x equals negative 5. And I'm going to divide by 2, and I end up with x equals negative 5 halves, which I'm going to convert to a decimal because it's easier for me to graph a decimal than a fraction for the most part. So I'm going to say my x-intercept is negative 2.5. Now, the reason we want the intercepts is because they're free points for us to kind of graph on our lovely picture. So I'm going to go to x at negative 1, 2.5 and put a free point. Now this is in a hole, so I can fill it in. Now I'm going to go to my y-intercept. I love y-intercepts because y-intercept is step 4 where I cover up my x's because I'm going to plug 0 in for them. Okay, so 2x plus 5 over x plus 1. I'm going to put 0 in here, and if I put 0 in here, it'll affect this too, and it'll go away. And I'm left with something nice and easy, 5 over 1, which is just 5. So on my y-axis again, because it's y-intercept, I'm going to go to the y at 5, and I am going to put the intercept, the point right there. This is great, because this gave me enough points to kind of sketch, if you will, or kind of graph, because I'm pretty accurate here, that we can't cross over these asymptotes. But I have this point, and I want to go closer and closer and closer to it. And I want to go closer and closer and closer to it. It kind of looks like an exponential. It's just the best. I love it. Sound effects make it much more enjoyable to graph. All right, so that's that guy. He's crazy. We're good. All right, let's move on to number 5. So number 5 is one that we're gonna give you it in this form, but then we're going to give you in factored form, because factored form is great because you can see very easily that you have a match. You made a match. There is the same factor on top and bottom, and I hope that you're screaming at this video, not at the top of your lungs, because don't forget you're at your house. You don't want to drive anybody crazy. But you're going to tell me, that's a hole, Miss Freibush. There's a hole. Matching factors give me a hole. Okay, so yes, I have a hole in this picture. Woohoo! Not only that, but I know the hole is when x is negative 6. So that x plus 6 over x plus 6 tells me, yes, there is a hole. And not only is there a hole, but it is at x equals negative 6. So at negative 6, boom, chicky boom, I have a hole, because those match. Womp, womp, womp. Now, when you find out you have a hole, you're done using those pieces. So the only thing I'm left with is the x minus 6 on bottom. Now, I can't just have a bottom without having a top. And if I put 0 in here, it'll go away. So I'm going to fill it with my favorite filler, number 1. So this guy I like to call, he's new function. All that x plus 6 did is tell me you have a hole. A hole means a value that is a small problem that we're going to not have filled up. So I'm going to use this new guy, 1 over x minus 6, and I'm going to plug in negative 6 to where the x is so I can find out the rest of my hole. So it's going to be 1 over, if I owe 6 and I owe 6 more, negative 12. Ms. Freibush, that is not a beautiful number. I understand that. So at negative 6, below it, I'm just going to put a hole there. I know that's not exactly 1/6. I mean, that pretty much takes up the whole thing. I'm just showing you, hey, there is a hole here. All right, now what we're going to do is the same exact thing we did over here, denom equals 0. Look for an x on top. Numerator equals 0. Cover up method. But we're going to do it with this 1 over x minus 6. So step 1, denom equals 0. When does my denominator equal 0? When x is equal to what value? And you hopefully are saying positive 6. That'll give you this guy. So here's x. Here is 6. Dot, 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 dot. There's that awesomeness. Horizontal asymptote. Now I'm going to look for an x in the top. Oh no, there is no x in the top. So step 2, x in top. Nope. That's actually the best case scenario for us because that gives me step 2 and 3. First off, I know this is going to be y equals 0 because there is no x in top. And then I know that there is no x-intercept because there is no x in the top. So if this is 0, this is none. And I don't need to do extra steps. All right, next, cover up method, my fave. Oops, I forgot to graph that guy. So let me graph y equals 0. Cover up method, whoop, whoop. So take new guy, because I already knew there's a hole. I don't need all that other stuff. I'm going to take 1 over x minus 6, and I'm going to do. So I have it y-intercept at 1 over negative 6, which is right about there. Now I know this part of the graph. And this is just an x to 1 power. If it is an odd, it's going to be like an odd guy, and it's going to be opposite. And notice I kind of sketch it. The last thing, end behavior asymptote, ha ha ha, use it again, hey hey hey. There you go. I have about 2 minutes to finish the last one. The last one is here. Hey, guess what? You have a hole. The hole is at -4. I'm running out of time. I just want to make sure you have the answer for this one. I would pause it personally and do this yourself. I'm going to take that, -4 minus 4, and I get 1 over -8. So -4, -8, make that nice hole. Vertical asymptote at the bottom, x equals 4. So at x equals 4, ooh, Miss Fredbush, I know I'm going a little fast, sorry. Horizontal asymptote, nothing in the top. Nothing in the top. I love it because it gives you 2 things for the price of 1. And finally, y-intercept, we're going to cover up our x, and we get 1 over -4. And I can graph this bad boy. Whee! Oh, it's ugly. Sorry, I'm trying to go very quickly so I can give this to you the answers. And finally, this guy matches that guy. 1 minute to spare. All right, my friends, at this point, we have gone over the notes. We'll pick up on class on Thursday and Friday. Have a good time doing these practice problems. All right, bye-bye.